Hello everyone, welcome back to my YouTube channel. Today we are solving the fifth problem from the blind 75 list, which is maximum subarray. So in this problem we have to find the subarray with largest sum and return its sum. So the subarray example are 2, 2 and 1, 2 1 minus 3 and so on, like 2, 4, and these are also the subarray 1, 3, 3 minus 1. Like we have to find the continuous subarray and the maximum sum. So let me erase this and let's find the solution. So let me introduce the brute force approach. So first we take an size of the array, and then we have taken the maximum as int min. So first we will fix the starting point of the subarray. So this loop will run from index 0 to n minus 1. So that will be index in starting and equal to 0, st less than n, st plus plus. Now for every starting point we need to decide where the subarray ends. So the ending index will run from current start index up to n minus 1. That will be int end equal to, so the starting point is 0 and the ending point will be the n minus 1, that will be n plus plus. So now we will initialize, we have both the start and end of the subarray. Now we have to calculate the sum of this subarray. So let's initialize a variable sum equal to 0, and then we use another for loop to calculate the subarray, and we will run and in this loop we will keep adding elements into a variable called sum. So that will be int k equal to start k less than equal to end and k plus plus sum plus equal to nums of k, and then we simply update the maximum sum. Update maximum sum, that will be max sum, the maximum equal to max. We will use the inbuilt function to save our time, and in the last we simply return the maximum. As you can see, the output is fine and we pass all the test cases. So the time, as we are using 3 loops in this, so the time complexity is big O of n cube, and we are not using any additional space, so the space complexity is big O of 1. So this solution works, but it is very insufficient for large inputs. Now let's move to the better solution. In the brute force solution, we may have subarrays like -2, -2, 1, -2, 1, -3, and so on. If we notice carefully, we are recalculating the sum again and again in the third loop. But do we really need to iterate over the same elements every time? No, because we can reuse the previous subarray sum. For example, if we already know the sum of -2, 1, then to get the sum of -2, 1, -3, we just need to add the previous sum plus the next element. So instead of using a third element to calculate the sum from scratch, we can keep a variable sum equal to 0. So let's remove the third loop, and simply we just, instead of initializing the sum equal to 0 here, we initialize in the above the second loop, and in the last we just add the previous sum and the next element, and that's, after that we will update our maximum answer. This removes the third element, so the time complexity improves from big O of n cube to big O of n square. As you can see, all the test cases are passed. The space complexity will be big O of 1. So now if the interviewer says big O of n square, that is not optimal, then we have to optimize it, which is Kadane's algorithm. The idea here is very simple. Instead of generating every subarray, we just keep a running sum. First I will initialize maximum to int min and sum as 0, and now I will start traversing the array from left to right. As you can see, the array is this, and at index the value is -2, so I add it to the sum, so the sum will become -2. Then I compare it with maximum. Since -2 is greater than int min, I will update maximum sum to -2. So that will be maximum equal to -2. Now I will check one important condition. If the sum becomes negative, I reset it to 0. So here, since the sum is negative, I will make sum equal to 0. Then I move to the next element. At index 1, the value is 1. Now the sum becomes 0 plus 1, which is 1. I compare it with maximum sum. Since 1 is greater than -2, I will update maximum sum to 1. Now the sum is positive, so I continue. At index 2, the value is -3, so the sum becomes 1 plus -3, which is -2. And since we have to drop the negative value, so the sum will become 0. Now I move to the next element. At index 3, the value is 4, so the sum becomes 4, and the maximum will also update, so it will also become 4. Now moving to the next index. At index 4, the value is -1, so the sum will become 3, and maximum is no touch. Then we will, at index 5, the value is 2, so the sum becomes 5. So now 5 is greater than 4, so I will update the maximum as 5. And we will continue this thing till the end. And finally our answer till the end will become 6. So the logic of Kadane's algorithm is keep adding elements to the running sum, update the maximum whenever needed, and if the running sum becomes negative, reset it to 0, because our negative sum will only reduce the answer for that next subarray. That is why this solution works in big O of n time, and space complexity will be big O of 1. So let me write the program. That will be sum, and we are adding all the values in this, so that will be now we will update the maximum as maximum comma sum, and at last if we will check if sum is less than 0, then we simply do it sum equal to 0. So as you can see, we have successfully submitted this problem. So in this video we discussed 3 approaches to solve the maximum subarray problem. First we saw the big O of n cube approach, where we generate all subarrays and calculate the sum for each one. This works, but it is very slow. Then we improved it to the big O of n square approach, where we avoid recalculating the sum from scratch for every subarray. And finally, we discussed Kadane's algorithm, which solves the problem in big O of n time, and it is optimal solution. So for interviews, Kadane's algorithm is the best approach to remember, and it is also easy. Like we just have to remember few things, and that's how we solve the maximum Subarray problem. In the next video, we will continue with the next problem from the Blind 75 series.